In this section, we are going to talk about VLAN and Trunking application in campus networks. Let's take a look to the overview of VLAN first. VLAN is Virtual Local Area Network, as you know. And each VLAN is one broadcast domain, and as we discussed before, they provide isolation to us. A VLAN or Virtual Local Area Network works in the same way as a physical local area network, with the exception that the hosts don't need to be located on the same physical network to be linked. Segmentation is the division of the network into groups, both for connecting specific groups with each other regardless of network affiliation and for isolation of groups for security reasons. Using a best practice approach to segmentation makes it possible to maximize bandwidth use while securing sensitive data. VLANs can be segmented due to first, maybe traffic patterns. Secondly, traffic types. Third is geographic group. I'm writing wonderfully, as you can see. And the fourth is department based. For example, this is a HQ of a corporate building, and this is the red VLAN, blue VLAN, and the gray VLAN. If I segment the VLANs using the department information, red VLAN users may be human resources, blue may be IT, and gray may be the finance. In a network design, a network administrator can design a campus network with one of two modules. The first one is local VLAN. The second one is end-to-end VLAN. In the local VLAN module, the local switch is connected to a distribution or core switch. This is where the routing is performed actually. Local VLANs will only exist between the local access switch and the distribution or core switch. In this module, you use different VLANs for different geographical regions. For example, as you can see that in the picture, we have accounting VLAN, that's VLAN 10 for this location, but for another location, we are using VLAN 30 for the accounting. For example, engineering using VLAN 20 in here, and engineering using VLAN 40 in other location of the corporate building. End-to-end VLANs are dispersed throughout the network on multiple switches. No matter where the user plugs in, they will always be assigned the same VLAN membership. Resources for this user will be on the same subnet. Management of end-to-end VLANs typically use VTP through trunked switches, and this allows for easier management. And as you can see that in the picture again, this building may be in Paris and the other building may be in Amsterdam, and here may be Tokyo. And if I'm using VLAN 1 for engineering in here, and VLAN 2 is IT, and VLAN 3 is finance in Paris, they are going to be same for Amsterdam and Tokyo too. And let's take a look to the voice VLAN concept now. Usually IP phones sit next to a computer on the same desk. They require the same UTP cables as computers use, and they use Ethernet. If you want to connect them to a switch, we usually use the method in the picture, as you can see. You probably want to separate voice and data traffic, and this is something we can do with voice VLANs. As you can see that in our figure, just one cable is coming to the IP phone, and IP phone has two ports. The first port is the local area network port, which we plug actually this cable coming from switch, and the other port is connected to PC, and that port is known as the PC port. And we are using different VLANs to carry data and voice traffic. In this example, we are using VLAN 30 and VLAN 10. VLAN 30 is carrying the voice traffic and 10 is carrying the PC data. And here is the configuration steps. For example, if we are using Fast Ethernet 016 port, we are going to the interface mode by typing interface Fast Ethernet 016, and we are typing the access port, switch port, access VLAN 10, and we are defining the PC data, and we are using the switch port voice VLAN command and writing the voice VLAN as well. Let's take a look to the Vlan Trunking again. As we talked in our previous sections, an access port can carry just one VLAN, and trunk ports can carry multiple VLANs. We can use VLAN 100 and just VLAN 200 for these two ports, but this guy can carry both of them. Here's the configuration steps of the VLANs. First, we are creating the VLANs in the configuration mode. For example, VLAN 100, and we can define a name. This is arbitrary. And we are defining VLAN 200 and the name of it too. Then we are going to the under interface mode by typing interface gig01, for example, which is this port, and we are defining it to an access port by typing switch port mode access, and we are making the VLAN configuration by typing switch port access VLAN and VLAN number. If you want to configure a trunk port, we are going under the interface mode again, and we are typing switch port trunk and an encapsulation protocol, which is a .1Q for now. And we are defining the trunk port by typing switch port mode trunk. And we are defining the VLANs that we want to carry from this trunk. And that's it. We can use two trunking protocols when we want to implement trunking, and they are ISL and .1Q. ISL is a Cisco proprietary trunking protocol which provides trunking for us, and .1Q is an industry standard protocol. .1Q has less frame load than ISL, and as a result, .1Q is more effective than ISL, especially in small frames. When .1Q load is 4 bytes, ISL is 30 bytes. Let's take a look to the .1Q native VLAN concept. Normally, a trunk port can send and receive .1Q VLAN tagged Ethernet frames. If the switch receives an untagged frame from the trunk port, these frames are forwarded to another VLAN configured as the native VLAN. The native VLANs between the two different switches must be same. Otherwise, the native VLAN mismatch warning is taken, and Cisco uses Cisco Discovery Protocol CDP when doing this. And please keep in mind that default native VLAN is 1. Here is how we can configure a trunk. We are going under the interface mode and we are typing the encapsulation protocol, and we are using the switch port mode trunk, and this line is actually optional. We can define it. If we can define, that's better, but if not, all other VLANs will go from the trunk port. To verify a trunk port, we are using show interfaces and the interface name and the switch port. Actually, we are seeing that the administrative mode, which means what we configured for this port, and the operational mode, which means what this port is actually behaving right now. Is it trunk or is there a problem? We can see by using this command. And the other command that we can verify the trunk port is show interfaces trunk, which shows us the interfaces making actual trunking at that moment to us. And let's take a look to the dynamic trunking protocol, DTP. DTP is a Cisco proprietary networking protocol developed by Cisco Systems for the purpose of negotiating trunking on a link between two VLAN-aware switches and for negotiating the type of trunking encapsulation to be used. It works on layer 2 of the OSI module, and VLAN trunks formed using DTP may utilize either IEEE.1q or Cisco ISL. In DTP, the following switch port mode settings exist, and they are access, trunk, dynamic auto, and dynamic disable. That would be better to underline this, guys. Okay. Dynamic auto, dynamic disable, trunk, and access. Access puts the Ethernet port into permanent non-trunking mode and negotiates to convert the link into a non-trunk link. The Ethernet port becomes a non-trunk port even if the neighboring port does not agree to the change. Trunk puts the Ethernet port into permanent trunking mode and negotiates to convert the link into a trunk link. The port becomes a trunk port even if the neighboring port does not agree to the change. The dynamic auto makes the Ethernet port willing to convert the link to a trunk link. The port becomes a trunk port if the neighboring port is set to trunk or dynamic disable mode. This is the default mode for all Ethernet ports. And lastly, we're going to talk about the dynamic disable, which makes the port actively attempt to convert the link to a trunk link. The port becomes a trunk port if the neighboring Ethernet port is set to trunk, dynamic disable, or dynamic auto mode. And here are the best practices of the VLANs and trunking. First, we need to avoid using VLAN 1 to avoid security issues, because VLAN 1 is the default VLAN. Second, we need to configure the trunk ports manually. Don't use DTP, please. You can face with big problems if you use DTP actually. And the third, we need to use .1q instead of ISL. We need to use SSH instead of Telnet for remote connections, because SSH use encryption for the connection. And we need to make the native VLAN different from VLAN 1 to prevent DTP spoofing.